Okay, shall we start? Okay, before we start, is there anyone not registered but here? Okay, how many? Raise your hand. One. Give me one, two. Not registered but still here. I'm willing to register. Okay, it's one, two. Okay, it's two people. Yeah. At the end of class, don't go, but please come up here and then talk to me so that I can know your situation. Okay. Are you guys freshmen? Freshmen? No, you're not freshmen. Is it your second time taking the course? Okay, so basically, I have no intention to increase the capacity, but I'm going to sign the form if you're a freshman and fail to register this course. I'll give it a chance for the freshman, but not for the retaker. Anyway, you can talk to me after the class. All right, so to see you all. This is multivariable calculus, section 5. You're in section 5. It's important because I teach section 3 also, and I'm going to use section 3 and 5. I'm going to share the resources for section 3 and section 5. So you have to keep what section you're in order not to confuse. So for the first 15 or 20 minutes, I'm going to explain the orientation and just a brief introduction of the multivariable calculus course. Why are you here? Didn't you were in the section 3? No? I confused with other person. Okay. All right. So here's our class information. My name is Hyo-sang Kang. My office is in G11. If you want to meet me in office, make an appointment through email. I'm basically free except for Wednesday and Friday. And here's our class time. You're in section 5 again. And the grading component, I'm going to explain that. So there are 3 components in the grade. The first one is the in-class participation. That means you have to actively engage in the class activities. So class activity requires you to discuss within your group on the topics that I lay out after the lectures. And you have to submit your file. So I'm going to explain what file is. You have to write the content that you discussed or thought about it or heard about it in the file, in your own file, and then submit it before you leave the classroom. And that will be the in-class activities. I'm not taking your attendance. I'm not calling your names. You can miss the class as much as you want, but I only judge by the content you wrote in the file that I just mentioned. At the end of the semester, I'm going to collect all the content you wrote in your file and then read what you have done, and then that goes to the first component of your grade. So that's the 30%. And the second component is the project. That's the 40%. We will cover 9 chapters in this semester. And each chapter contains the project. So there's basically going to be 9 project topics. You don't have to do all the 9s. You can pick 2 and do one before the midterm and do one before the final. And you have to present both of them. And you also do the project in group. So we're not going to make the group right now. Group will be formed after 2 weeks later. But once you fix your group, you have to concentrate on the topics, the project topics. I'm going to give you what the project topics are. So you can just look at the topics right now and then see if which 2 of these interests you. The first one is about the CAPTCHA, making the CAPTCHA. So do you guys all know what CAPTCHA is? Yeah, probably you've seen one when you register into website that asks you whether if you're a computer or not. So you ask you to write the letters or digits based on the image that you see. That's the CAPTCHA. So we're going to use our concepts of vectors and matrices to make a CAPTCHA. And the second topic is about making a calculator. So not going to make a fancy calculator. We're going to just mimic the old calculator that you can see anywhere. But it involves, we're not going to use all the fancy function that's already implemented. We're going to only use the basic arithmetics like plus and multiplications in order to make a calculator. So that involves how the basic functions such as exponential functions and logarithmic functions are computed based on addition and multiplication. So then we also need the concept of sequence and series. And the third part is the contour plot. Of course, there is a function that draws the contour plot for you, not in the Python and also in the MATLAB. Oh, by the way, all the project should be done in Python language, okay? So we're gonna use lots of Python programming throughout the semester. So in the third project, we're going to implement our own algorithm to make a contour plot for 2D and 3D. And fourth project is about spring oscillation. So we're going to use the concept of vectors to draw the spring graphs, and also use the concept of differentiation to make a simulation of the spring oscillation and also pendulum oscillation. So you can see that these materials, most of them are actually not entirely about the multivariable functions. So you can see that I'm going to cover the single variable function material in our semester. The reason is because officially you learned about the engineering mathematics on the first semester, right? It's supposed to cover some part of the single variable calculus, but not systematically. So I'm expecting you to have somehow good understanding of what the single variable functions are, but not deep understanding of the theory of single variable calculus. For example, if I ask you what's the definition of differential, what's the meaning of differential, you might say something based on what you learned in the high school, not based on what you learn in the engineering mathematics. So I'm going to cover these concepts, the single variable function concepts, in this semester. And then on the fifth project, it's about the visualizing heat flow, and this involves the partial differentiation. And sixth project is implementing a simple neural network. So this is the highlight because whenever you learn the differential multivariable function or multivariable calculus, you should be able to understand the core idea of a neural network. Or for example, if you if you heard about how a convolutive neural network works, it's based on gradient descent, and they kind of, if you see any YouTube videos, they kind of explain the rough idea of how it works, but you should be able to implement the CNN on your own if you have a proper idea of what's going on in the multivariable calculus. So that's what we're going to do. We're not going to make a complicated CNN here, but a simplified version of it. And that's going to be the application of derivative. Okay, so the seventh project is computing the length of a curve using Crofton formula, and this involves integration. And eighth project is the simulating electromagnetic fields. It includes vector calculus and vector fields. And the last project is about game making of area of polygon. So I'm giving you the idea of how you get the area of a polygon using the green theorem or Stokes theorem. And you can use that topic, you use that keywords as part of your game making. All right, so that's the 9 project. What you have to do is first pick, I mean, not pick, you have to pick officially right now, but just keep 2 out of 9 in mind so that you can concentrate on. I'll just lay out, I'll lay out the topics that we're going to cover weekly, and then you can see which topics could be fit in which part of the semester. So because there are, as I said, there are going to be you're going to be complete 2 projects throughout the semester. One project should be done by the end of half of the semester, and then the second project should be done by the end of the entire semester. So you have to pick one among like first 4 or 5 and one among 5 to 9. All right, so that's the 2 project component. And the last one is the report. So again, you don't have a midterm and final. The report consists of 30% of your grade. And this report could be written in group, or you can write your report on your own. So even if the project has to done in group, you can write on you can say whatever you want to say about the product that your group made here, because everyone can have different thoughts on what you made. So also you can write one single report in one group. So it's up to you. Or you can even divide your group into smaller groups so that you can submit 2 or more reports. So I'm going to give the proper format of the report, but you can make your own. But I'm going to ask you to write in the file format, the specific file format called Markdown. And this Markdown file format is going to be the only requirement that I'm going to impose on the report. And I'm not asking you to write a lot of report, just make it into 1 or 2 page based on A4 size paper. You don't have to write a lot. This is a grade scale that I use every semester, every course. So if you get 90 or above, you get A+. That's after rounding up the scores. There are 2 conditions that you can get F. So that's the first one is if you don't do the project or not submitting submitting the report, you'll get an F. Okay. So, and if I spot you using a ChatGPT on your report, then that also will be an F. So it's when it's obvious that you just copy paste what ChatGPT said, because ChatGPT generally have a certain pattern of writing the sentences. So if I spot them and then it's true that you just copy paste the ChatGPT, then it's F. Okay, so here's the weekly schedule. You can just see the keywords for now. It's not fixed, but I'm trying to follow as much as possible. For today, we're going to have orientation and cover the basic stuff about vectors and the matrices and project 1, and the sequence and series for the next week. And for the 3rd week, we're going to cover the functions and continuity. And all these project numbers are, you can consult this list of projects here. And the 4th week, we have lots of holidays. So we're trying to just cram everything in non-holiday days. So these are official holidays. This day is my personal, because of my personal schedule, I'm not sure whether I can give a lecture or not, but I'll announce it before. So anyway, so we're going to cover differentiations, and by the end of week, by the week of 7, we're going to cover the partial differentiations. And on the week 8, we'll have a presentation. So presentation for your project, the first project you picked. And from week 9, now the chain rule, Lagrange multiplier, Hessians, definite integral, multiple integral, and we don't have a holiday from then. Line integral, surface integral, Stokes theorem, and divergence theorem, and the last presentation week. So you might wonder if how would I do the project that is just before the presentation week? For example, I want to do the project 9, but it's covered right before the presentation week. How could I do the project 9? So that might be the question. So I'm going to ask you after 2 or 3 weeks, what's your preference? What project do you want to involve? And then if someone wants to do the project that is going to be covered just before the presentation week, I'm going to spend an extra hour in the mentorial seminar to explain that project for the people who are going to do that project. Okay, so for example, if I want to do the project 5 to present on the midterm week, now it's going to be covered after the presentation week, so you cannot wait for that. So if there's someone who wants to do the project 5 as a first project, then I'm going to spend so hour or two of around week 3 or 4 to explain the project 5 ahead. Of course, we're going to cover the project 5 on the day that's going to be scheduled, but I'm going to explain that project for some of us who actually wants to do that ahead. Okay, so that's the plan. Okay, so all of us will just know what the projects are, but you only need to pick two among them, to do more. So I'm expecting not just following exactly what I did in the class about the project. You have to do extra work to improve what we have done in the class on the topics, on the project topics, and that's going to be the thing that you have to present on the midterm week and the final week. Okay, so that's basically it. Is there any questions? Any questions? Yes. How many people should be in a group? Good question. So it's a good time to show you the groups that I generated here. So, okay. Okay, here you're in section 5. Here. It's a bit slow. I'll just, okay. Let's change this. I think it's because I've shared this screen, why it's so slow. Normally it's not this slow. So this is the group for today. So you can approximate the number of groups for the project, about 5, but it depends on situation. So if there's a situation that only one person have to be left over, then I'll make a group of 6. But mostly it should be around 4 to 6. for each group. So 5 is ideal. It's not ideal, but 3 is actually the ideal number for a group. But we have so many people in our class, so I think the 5 is the optimum. So I'll just make it larger since this issue was brought up. So what I'm going to ask you is, oh, it's too big here, is move your seat based on the group assigned. So your group is the number next to you on the left. So there are 10 groups, and I've seen that there are 2 people not registered. That means your names are not here. You can sit anywhere you want. This is not the group for your project. It's just the instant group for today, only for today. So because every day, every class, we're going to have a discussion, and I want to shuffle the group every class so that you can get to know as many people as much as possible. So how about, what about you guys pick up your stuff and then move to the seat nearby the numbers that you can see on here. So there's a stand on the table. Move your seat next to your numbers. So you can sit on front and back. Some people can sit on back seat. There. So you have to sit front and back, not in the same row. Okay. So you have to gather around front and back. What number are you in? 9? So go to here. Are you in group 1? Come here. So you have to sit front and back, not in the same row, okay? So that you can have a near each other, so not in the same row. Yes. Who's in group 8? You guys are in group 8. Group 1. So how about you guys move one seat left to the left here? Yeah, move one seat left. Everyone move one seat left. So you can sit on this.
Where is it? Group 2.
Group 2?
Yeah.
Where is group 2? Oh, here. Group 2. Okay. So you can see after I give a brief introduction to the material that we're going to cover, what we're going to do in this class. Meantime, I want you to go to the Notion site. First of all, if someone is not registered, then this is our Notion site. If you go to the LMS, I posted one announcement with a link to this site. So go to the LMS to access to this Notion site. And if you're not registered, you can use this QR code to go to this site. And this Notion site contains all the information you are going to need throughout the semester. I'm not going to use LMS to post any information about the course, I'll just post or upload the material in this Notion site. So you can just bookmark this site. Anyone have trouble going to this site? Raise your hand if you have any trouble. No? Okay. So I'm going to briefly tell you about the stuffs here. So lecture notes will be uploaded in this page, the YouTube site. And the GitHub is going to be the place where we store all the information of your activities. So if you go here, it's a public repository. I'm going to close out everything after the semester is over, so you don't worry about having your personal information there. I don't think there's anything personal in here. So the week one, if you go here, it's basically the same material you're going to see shortly. It basically contains all the personal files. So you're in group section 5. So section 5 folder has lots of files with your student ID. You can find your student ID here, and each file is a markdown format file. So that means you can write anything in text and then preview that text in the markdown format. So this is going to be the file that you have to write your activities. So whatever you discuss in our class, whatever you thought about it or you discussed it or you heard about it should be written here, so that it's not only for your record of what you learned, but also for record of your activities. And it goes to the first component of your grade. And the live share, it's a temporary tool. I try to use the Replit for you guys to access to this file that I just show you in the GitHub. But it doesn't work, so I used a live share as a temporary solution. So if you click this live share, I think some of us already done that. You can access to the current window that I'm looking at right now, and you can access the directory that I just showed you, and you can edit the file, your file with your ID. However, you have to log in. So if you just click, then you without login, then you can view the file, but you cannot edit. So there's somewhere you can click and log in to this Visual Studio, or maybe through the GitHub ID. So anyway, if you click this link and then properly logged in, you should be able to find your file and then edit it. And all the lecture slides will also be posted on here. So we're going to cover these two today. So for now, we don't have to, you don't have to engage in a discussion or try to write out anything on the file. But after we cover this first lecture, I'll tell you what to do. Any questions before we start? No? No questions? All right. So. Okay. All right. So the first chapter is about vectors and matrices. So first one, vectors. So I'm pretty sure that you heard about the vectors, but the usual concept of a vector is something that represented by an arrow, but that's not what vector is. So I'm going to guide you from the intuitive definition of vector to the abstract definition of vectors. So let's start from the intuitive definition. So I'm going to use the term position vector to relate that object called vector to something about the arrow. So position vector, two-dimensional position vector, is something determined by two-dimensional points, two two-dimensional points, P and Q. So here P is considered to be the starting point, and Q is considered to be the end point. And the vector P to Q, just vector PQ, is considered to be the pair of numbers consist of these formulas. So once you have the points, 2 points, then you can determine two-dimensional point vector called PQ in this formula. But whatever that formula is, the essence, the core concept of vector is just a pair of numbers. Okay, pair of numbers, right? And you can do the same thing with the three-dimensional vectors. If you have two three-dimensional points, and if you know what the coordinates of those two three-dimensional points, then you can define three-dimensional position vector based on their coordinates, which consist of three numbers. So that means three-dimensional position vector is triple of real numbers. Okay, so the essence of vector is just you collect the real numbers as a component. So, of course, you can visualize your position vector as an arrow, and this is how you do it. So throughout the semester, as I said, you're going to complete your project in Python language. So you're going to exercise lots of Python programming. So it's not considered as a programming still, but it's a nice exercise to begin with. So how about we spend a little bit of time to do this? So I'm going to, so if you already have on your computer the Python environment, just open up your Python environment right now. If you don't, or you have a tablet instead, then I'll tell you the easiest way to prepare your Python programming environment. So go to the Replit. It's a REPLIT, Replit. Okay. So I already logged in, but if you go to the Replit and you have to register with your ID, Google ID or whatever, and you log in, then you'll be able to create a REPL, and it pops you the proper environment for programming. So if you, as I said, if you have a laptop and you have your own Python programming environment, open up right now, or go to the replit.com, and then log in. Take your time, and then if you don't know how to do it, raise your hand or ask your partner next to you. Okay, so is there anyone who's not logged in Replit yet? Not ready for Python programming? Okay, so do you need time? Do you know how? Just need time? Okay. Do it quickly? Yes. Do you know how? Oh, you didn't bring anything. Okay, so sorry for sorry for that. So you can sit next to her just to share the screen. So yeah, just move your seat to her. All right, so are you guys done? Logged in? Okay, so anyone not logged in? Okay, so that all logged in. Okay, so you can create REPL. Click create REPL here, create REPL, and click Python. And the title is automatically generated. You can do anything you want. And if you're not paid, you can only create the public REPL, but it's fine. Nobody can find your REPL. So create REPL, and it opens up the Python environment. So I'm going to write the code here. So you can write the code here. So what's the code? Let's close this one. This code. So let's do together. So you can pop this slide on your on the other side of your screen because it's already uploaded on the Notion. So I'm going to just do this together. So here, let me close out some of the screens here. Okay. All right, here. So import matplotlib as plt, and I'm going to draw the quiver, the arrow here. So plt quiver. So what's the vector that I'm going to draw? I'm going to draw the position vector starting from the origin, whose coordinate is 0 and 0, which ends at 1, 2. Okay, so that vector has component 1 and 2. So it has to go this way. So first two numbers that you put it into quiver function is the starting points, the coordinate of the starting point. That's a 0, 0. And the second two numbers that you put it into quiver function is the x and y component of your vector. So that's 1, 2. Now, you can draw it only with this 4 information. Let's see what happens here. So I'm going to, but basically if you have your own Python environment on your laptop, you can just simply plt.show so that the window pops up for you. But we are using web browser, so I don't think this works. So I'm going to save the image file. I'm going to output my graphics on the image file instead. So I'm going to use this. Okay. So PLT quiver means that I'm going to create an image of quiver. Quiver is the arrow, basically. And PLT save means that whatever I draw in the image or graph or window graph, I'm going to save it in the file name quiver.png. Then I'm going to just hit run here. On top of the screen, there is a button, the green button. If you click it, it automatically installs the necessary package here. So we are importing the package called pyplot in the, sorry, so it's a typo here. Why is it matplot? So it's a matplotlib. So, okay. Yeah. So we are using the pyplot package in the matplotlib library. So we are importing as the name, abbreviate name for as PLT, and we're using the functions in that PLT package, pyplot package, and we're accessing that with this prefix PLT dot. Okay, so yeah, it's done here. So you can see that the quiver.png, the file is created. Anyone have trouble with doing this? Raise your hand if you have any trouble. You have trouble? Are you using Replit? Or are you using Replit? Okay. So check if you had misspelled any of this. Sometimes misspelling causes a problem. So I'm going to show you the image file here. So this is the image file that doesn't really look like a proper arrow that represent the arrow from 0, 0 to 1, 2. It's too small, right? I think the direction is somehow correct because it points 1, 2, but the size is too small. It's because it's not scaled properly. So we have to give some options on the scale. So let me modify this a little bit more. So quiver option. So x. So I'm just going to use the same here. So here we have quiver parameters. So angle is xy, scale is 1, scale unit is xy. So the one thing good about using Replit is it uses some AI generated code. So sometimes you don't have to write everything by yourself. So this means that they're going to use the angle in the scale of xy coordinate, and the scale of 1, it means that it's going to make an image of arrow 1-to-1 scale, and also the scale unit for x and y coordinate is same as x and y. So once you've done this, and so I forgot putting this parameters as a option for the quiver function. So quiver parameter should be put it into an option value for the quiver function with this symbol here. So this is asterisk, double asterisk. Okay. So then if you hit run again, you get a proper image. So let's check this one. I think there's some error here. So quiver, let me check if I forgot this angles S here. Yes. Okay, so let's hit it again. Yeah. So now you have a proper image of a quiver, but the window is too small. So the quiver image, quiver arrow is from 0,0 to 1,2, but the window size is too small. You can see that it ranges from minus 0.05 to 0.05. So we have to enlarge this window scale, window range. So I'm going to put the option for the window size. What is it? So x limit from minus 1 to 3, y limit from minus 1 to 3, and that should be fine for creating the proper image of quiver. Now you can see that the quiver isn't fully shown here because I enlarged the window size for x scale, x from minus 1 to 3 and y from minus 1 to 3 too. So you can see that the arrow from beginning to end. So this is how you can visualize the vectors here. So I'll give you more time practicing this Python. Meanwhile, we'll just continue our material. So not only you can visualize the two-dimensional vector, you can also visualize three-dimensional vectors. So here we have to use 3D projection of three-dimensional vectors. So therefore, we need this line here. We're going to practice later. But before, let's talk about property of vectors. So vector is not a point. Okay? Point is just a point, but vector, what differs from point is that it can be added together. So if you have two-dimensional vectors like this, you can add them together to make another vector. So the addition of two vectors is simply adding component-wise the x values and y values. And same thing for three-dimensional vector. You can add two three-dimensional vectors. So it can go on. So if you have any n-dimensional vector, you can always add together. And another property of vector is that you can scale it. That means you can make it longer or shorter, or reverse the direction and so on. So for example, if you have a constant k and you can multiply that k to the two-dimensional vector to get another two-dimensional vector by scaling each component with the same constant k. The same thing for three-dimensional vectors. Okay, so what's that mean? So let's say we have a PQ vector where P is 1, 1 and Q is 2, 3. So if you take the 2 times of PQ, that means you make the length of the PQ vector twice from the original, right? So this is our 2 times PQ vector, okay? And what happens when you multiply minus values? So what if you take the -3 and multiply to the vector? Minus means that you reverse the directions. So PQ was originally directing this direction. Minus means that you're going to the opposite direction. And 3 means that you're multiplying 3 times. You're enlarging the length of this vector 3 times more than the original length. So you can do this for any n-dimensional vectors. This n could be 2 or 3, but it could be 4, 5, 6, and so on. You can always add 2, 3 n-dimensional vectors, and you can scale any n-dimensional vectors. So basically, if you want to say anything as a vector, that must have these two properties. That these object called vector must be able to add it together, and a vector can be multiplied with any number, here in this case the real number, to get another vector. And what's good about the vector is that you can think about this concept of linear combination. So basically you combine vector addition and scalar multiplication on number of vectors. So if you have n vectors, v1 to vn, you take the scalar multiplication of each vector and then take the vector sum, you get another vector like this. So this form is called the linear combination. And what does that mean is like this. If you have two vectors, say v1 and v2, pointing in these directions, so here on the right, you can see v1, v2 in these directions. And I put the grid line in the gray color so that you can position your vectors correctly. Then what it means by taking 2 times of v1 and then adding v2 on top of it is that you go twice the direction of v1 like this, and then you go v2 direction from there. So that's where you ended up. So it's starting from here, ended it here. So that's the vector that is representing. So you can arithmetically check whether this is actually true. So just plug in the numbers here, and then you just take the multiplication and addition to get the actual components of the vector W. But it's important thing that you know what's the meaning of this addition and linear combination. And so now we are going to the concept of vector space. What is the vector that, vector is something that you can add it or multiply together, or scalar multiplying, that has a scalar multiplication. But what if you take all the vectors of such kind? So that means that you have a set of vectors, and the set of vectors is called the vector space. Okay, so for example, if you have a two-dimensional vector, you combine all the two-dimensional vectors. It's called the two-dimensional vector space. So of course, if you take the vectors whose starting point is the origin, then you would see something like this. Of course, this is just a finite number of vectors, but in an ideal situation, this vector space contains infinitely many vectors, so it will fill up all this plane, but I'm just showing you the finitely many of this. And we're going to denote two-dimensional vector space and three-dimensional vector space as just symbols from now on. So two-dimensional vector space consists of two-dimensional vectors like this, and three-dimensional vector space consists of this three-dimensional vectors. And so I'm just introducing a lot of concepts here. We can talk about the inner product between two vectors. So it's not a natural concept that comes with the vectors, but once you have a vectors, you can impose operations like inner product. Simply saying it's something like you're multiplying vectors, but it's really not a multiplication. What you get after inner product is real number. Okay, so you have v1, v and w, and you take the inner product, what's the result? The right-hand side, you see that it's the multiple and adding of the real numbers. It's a real number, okay? So inner product is taking pair of vectors and giving you a real number. And it requires the same dimension of these two vectors. So the vectors that you're taking inner product with must be in the same dimension. You cannot take inner product between two-dimensional vectors and three-dimensional vector. Okay? And once you have the inner product, you can define the norm. The norm is basically the length of vectors. So if you have a two-dimensional vector, the norm of two-dimensional vector is the square sum and square root of sum of squares of each component. And you can see that this is actually same as the square root of inner product of V itself. Okay? The same thing for three-dimensional vectors, right? So the norm is actually the length of a vector, but it's length of arrow representing the vector. Okay, so you can see that this vector, this formula is actually the formula of a length connecting the point origin 0, 0 to the point x, y, right? That's a Euclidean length. Okay, so you can consider that as the length of actual arrow representing the vector. And once you have the concept of a length of a vector, you can define the concept of unit vector, which means that the vector length is 1. And whenever you have non-zero vectors, you can always normalize that vector, meaning that you can rescale the length of vector to be 1. So whenever I normalize a vector v into a unit vector, I denote it by v superscript 1 here, and this is computed by v multiplying the scalar 1 over v here. Okay, so I'm just dividing out the length of a vector so that I get the unit vector. So here's the important theorem. It's always important here. So what you have to understand about the inner product is it's, of course, giving you the concept of a length, but what it really gives you is the concept of direction. Okay? So look at this formula and look at the statement. If you have two vectors, OP and OQ, whose lengths are 1, and if you have an angle between these two vectors as theta, so we are sharing the same starting point, and we have 2 points of these two vectors, and let's say theta is the angle between, then it says these equations are true. So what's on the left? It just computes the inner product, right? What's on the right? It's about the angle, okay? So angle is the geometric some value, right? Angle is some geometric value, and it gives you the idea of a direction. So the angle is the way you can measure the direction. But on the left-hand side, it's just the inner product. Inner product is just arithmetic formula. It's nothing about the angle, right? But it says that inner product is actually giving you information about the angle. So you have to think in otherwise. It's not the angle that comes first, it's the inner product that comes first when you try to think about the concept of directions. So you can think about direction when you have the Cartesian coordinate, but suppose that you're floating in the space without any reference point, reference angles, or reference axis. You might be in an upside down position and you don't even know what's up and what's down. Now in a random and general position, how you decide which direction you're pointing at, or at least whatever you're trying to conceptualize the direction, how would you describe what direction you're trying to talk about? It's always within the concept of the inner product. So let me explain a little bit detail about this. So for example, suppose that I have a vector v of length 1, okay? And all I know is the information about the inner product with v and some other vectors, e1 and e2. So let's, for example, for the very simple case, let's say e1 and e2 are the standard bases, 1, 0, and 0, 1, okay? And I know that the inner product, suppose that I know the inner product with these two vectors is 1 over square root of 5 and 2 over square root of 5. So that gives me the information about the angle between v and e1 and e2. Okay. So what does it say? So v is somewhere around here, and it has to consist some angle between them. So this is theta 1 and this is theta 2. And I should infer from this equation about the cosine value what the theta 1 and theta 2 is. So if you try to find out the theta 1 satisfying this first equation, it's something like 68 degree, not in radian, it's in degree. However, there's other values, like there are infinite many. Minus 68.2 degree also satisfies this first equation, right? So if I have only the first equation, then what I can say about the direction of vector v is that it either points 68.2 degree away from this E1. It could be either this or this, right? So I cannot uniquely determine the direction of v. It's only when I have the second equation of the inner product that I can single out direction of the vector v. Because now the second equation says that the angle between v and e2 is 21.8 degree. That means, if of course, again, if I don't have any information about the first degree, then v is either pointing this direction or that direction, or it's either this or this. Now, you have two choices, either this one, this, or this one, or this. So only this direction satisfies both conditions. So now you can determine the single unique direction of a vector. So you can only determine the direction using the inner product, okay? So, and you need to have a reference so that you can talk about the directions, right? So that the angle is not the concept comes first when you talk about the direction. It's the inner product. Okay, so inner product is something that you give the concept of a vector, direction of a vector. So whenever you learn about the vectors, people usually say that vector is something that has the length, a size, and direction, or or direction. So it's not really the characteristic of vectors. Vector is only consists of the concept of vector addition and scalar multiplication. It's only after you take the definition of inner product that you can say anything about the direction of a vector. Okay, so inner product is the direction. So let's talk about this example here. So now it's a little bit different situation than before because we have two reference vectors, v1, v2, which are not perpendicular each other. They're not perpendicular. But still, I have information about the inner product. I'm assuming that my w is unit vector, and I'm assuming that my inner products are given. So how would I determine the direction of my w vector? So first of all, let's use the first equation. It says that if I have theta 1, then the cosine theta 1 is 3 over square root of 10. That means I need to find the angle theta 1 that gives the cosine value close to 3 over square root of 10. There are two, so either this direction or that direction. I cannot decide the unique one. So then I have to go through this second equation, which means that I have to find theta 2, which is 1 over square root of 2. So it also gives you two choices, either this or this. Now, the omnidirection that satisfies both condition is this direction, right? So you can say that the direction of W is where it has an angle between W1 as 18.43 degree and angle between V2 is 45.6 degree. So that's how you try to describe the direction of W. Okay. Now, what would happen if you have three-dimensional vectors? Now, I said if you want to determine the direction of two-dimensional vectors, you need inner product with two vectors. Okay. Now, if you want to determine the direction of three-dimensional vectors, you need three pieces of information with the inner product with three different vectors. For example, I suppose that I know that the vector W is a unit vector, and I know the information inner product with V1, V2, and V3. Let's try to use the first piece of information. Now, the inner product is 1 over square root of 10. So here, this one is V1. Okay, so it means that my vector W is in the angle between V1 with something theta 1, whose cosine value is 1 over the square root of 10, right? So I'm not sure how much that is, but it has some angle. And there are not even finite choice of such vectors. There are infinitely many vectors that has an angle between W and V1 with cosine value 1 over square root of 10. That's the cone. All the vectors consists of if I collect all the vectors whose angle between the vector and V1 is cosine, whose cosine value is 1 over square root of 10, it gives me a cone. Okay, so any vector lying on that cone satisfies this condition. So not even finite. So how about the second equation? You do the same thing and you get another cone. So here is V2, and this is the cone that consists of all the vectors satisfying the second inner product equation. Now, how would you determine the direction of W? So you have to find out the intersection between these two cones, right? But if you take a general position of two cones, of course, the tip of the cones shares the same point, but these two cones could intersect in two different positions, right? You cannot single out. Sometimes, if you're lucky, then the cones are barely touch each other, so you can have a single direction, but generally, they always intersect in two positions here. So you need to use the third piece of information about the inner product in order to find out the unique direction. So what I'm saying here is you need three inner product to find out the direction of three-dimensional vectors. Okay, so let's close out with this observation here. So we're going to talk about the orthogonality here. What it means is that whenever two vectors are orthogonal, which means that it's perpendicular, you will notice that these inner product is always equals to 0. Now, it's obvious when you're talking about the two dimension, and it could be obvious if you do a little bit of calculation for three-dimensional space, but I'm saying that this orthogonality also is defined through these inner product equations. It's not, the orthogonality is not the geometric concept. It's not from what you see in the picture. It actually comes from the equations. Whenever you have two vectors satisfying this equation, it's called orthogonal. And if you're using the inner product we defined before, if you draw the vectors as an arrow, you can actually see these two vectors are perpendicular. So how about the parallel vectors? Two vectors, v and w, are called parallel if one is the scalar multiple of another. So basically it means that it's going in the same direction. So whenever you have two vectors, such as v and w in the picture here, you can decompose one vector into sum of two vectors, let's say v perp and v parallel, so that v perp is always perpendicular to w and v parallel is parallel to w. This is called the orthogonal decomposition. Okay, so how would you obtain the orthogonal decomposition? Well, let's talk about this first. First, you need to make a projection of v on the vector w. So that means you're just shed a light on the vector v in the perpendicular direction of w. So that means you get the shadow of the vector v. That's going to be your parallel vector, v parallel. And how would you obtain the v perp? So I said v is v perp plus v parallel. So once you know, of course, you need to know what v is. And by taking a projection, you know now what's the v parallel. So v perp is going to be v minus v parallel. Okay? So I'm going to use that idea to explain this situation, and then going back to how you get the v parallel here. So same applies to the three-dimensional vectors. So I'm going to decompose our vector v, the three-dimensional vector, into v perp plus v parallel here. V parallel is parallel to the another three-dimensional vector w, and v perp is perpendicular to w. Okay? So you can check whether these two are actually v parallel and v perp and v parallel. First of all, an easy thing you can check is that this is considered to be v parallel. You can see whether this is the multiple constant scalar multiple of the w, because if you take the 2/5 multiple on each component, you get this part, right? So this is v parallel. So how we obtain this is by subtracting this v parallel from 1 to 0, original vector v. Okay, so I just draw these two vectors here. All right, so the question is, how do you obtain v parallel? As I said, you can use the projection. So how would you find or compute the projection? So it's by this formula. So before we go through how you obtain this formula, let's see what it means. So first of all, this numerator and denominator are real numbers, okay? They're not vectors. So real numbers, the ratio of real number is a real number. So what it means is that basically scalar multiple of these number on the vector w, okay? So that means it's parallel already, okay? So the question is how much you have to rescale the vector w in order to make it into as a projection of v. So look at this picture here. So I made a specific example, but what it happens here is that you have a length of vector v, and you want to find out this length, right? This length. So if you know the angle between two vectors, you can find this length by multiplying cosine theta with the length of vector v, right? So let's take this in consideration. So I want to find the projection of v by multiplying the length of a vector to the direction. So here is the direction. So I want to normalize. This is normalized. So I just want the direction, but not the size. So that's why I've normalized here. And I just want to rescale the length like this. And let's think about how you get the cosine theta. As I said, cosine theta is the inner product of two vectors, which are normalized. So here, v and w can be normalized so that their inner product becomes the cosine theta. So cosine theta is equals to V normalized inner product W normalized. So this whole thing is the cosine theta. And then put the things back here, W normalized. All right. So let's cancel out things here. So we have V lengths here canceled out, and we have two W lengths. So we have W length square and V inner product W multiplied on the vector W. So what is this? So we have a numerator same as here. And what's the denominator? We have square of the norm of W. What was the norm of a W? It's the square root of W inner product with itself. So square of norm is same as W inner product with W. So what's exactly in here? So exactly here, right? So you can directly use this formula to compute the actual projection of W in this example, or you can think about how you can derive it. So the important thing is not just to try to memorize this formula. Think about how you derive this formula. Then you never forget the formula here. All right. So before we move on to the discussion, is there any questions? So I'll try to go as fast as possible when I do the presentation, because I want to be compact I want to divide the lecture part and discussion part. But you can always stop me anytime if you want to understand deeper, or if you want to see extra examples. Or you can wait until my lecture ends, and also you can ask to go back to specific slides and explain more. So if you have any questions or explain more extra explanation, let me know right now. No? Okay. So how about we, all right, so do some work together from here. So we already done this. So how about we do the second part? So let's try to graph the three-dimensional vectors. So you can just simply copy this code, or you can try out on your own and see what each options do. So I'll give you a little bit of time, like 1 or 2 minutes, to do your own, to do it on your own, and then after that you can discuss or compare and share your result with your partner sitting right next to you. Okay, so spend some time to discuss with your friends sitting right next to you, and then after discussion you can bring up into entire group and discuss as a whole group. And then I'm going to ask each group how you came up with the result and how you did it. And we're gonna share all the different methods you come up with. All right, so try to make an image like this. And I'm going to walk around to see how you are doing. And if you're having trouble setting up the environment, let me know. What's your question? What is it? It's a
screen vector.
replit.
Yeah. Yep.
And what's your problem?
There has to be a vector, because when I run the program,
Okay.
there's no.
Yes, so that's because it's a window, it's a web browser, so this doesn't work. So you have to use the save fig.
What?
Do you remember what I did in the
Yeah.
two-dimensional vectors?
Yeah.
I used the save fig command. Save fig.
Yeah.
Yes. So you have to use the same thing for here. save fig, and you have to specify the file name.
Okay.
Yes.
Maybe my content pattern, but
Okay.
this runtime is too long to make visuals.
Yeah, but I think you made a mistake somewhere.
First one was run for second.
So it's your job to figure out what's wrong with the code here. It's nothing wrong in here, but if you're using replit, it doesn't work properly because the last command is plt show, which makes which pops up the window, the graph window. But if you're using replit, you're using in a you're using rep browser, so you cannot pop up a window for this graph. So I used a different function to save that output into an image file, right? So if you properly followed what we did here, it's not the show here, right? All right, so take your time to discuss with your partner right next to you and see if your partner got the result or not, and try to figure out what's wrong or what went okay. Run. What is it? Can't open file here. So you're trying to run this code, but it tries to run the main.py file in the folder 01. There's no folder like 01. Okay. It's only when if you want to do this, if you want to run this file, you have to go to the shell here, console. Shell, yes. Oh, where is it? 01. 01 is just the name. Oh, sorry. So just the name. So I think, yeah, you have to manually run this Python 01 py. Yeah, so now you have a peek. Okay, so let's bring up your discussion into a group so you can share your result and code with all members in the group. So I'm going to ask each group how you got the answers and what was the result, how you got it. You done? How about you guys all? Are you in group 1? No? So you guys are in group 1. Okay, so how about you guys talk each other? You just turn yourself around. Turn yourself around. Did you done? Are you done? No? What? Yes. So but you can go to the Replit. It's a website. Okay. So talk each other how you did it. If you don't know how to do it, you can teach him and teach her.
What part do I have to fix it?
As I said, this doesn't work in the web browser.
Yeah.
So Replit is just a temporary solution. You have to install Python on your computer. All right, so I'm going to ask some of the group your result. Let's see. Okay, so how about where's group 6? Group 6, yes. So the person on the front column is the leader. So I'm going to ask him or her, how about your result, group result, group 6, Yuseok? Where is Yuseok? Yes. So did your group get the image of arrow? Okay, you get the image. Okay. So how about group 9? How about group 9? Where is group 9? Oh, here. Okay. So Chang Minsu? Yeah. Did you get the image? To get the figure? Okay. All right. So well, basically, you have to work on your own about the Python program. I'm just letting you to have the practice of discussion, practicing the discussing within your group. So let's talk about other examples here. All right, how about all right, so how about this one? Okay, how about this one? So I'm also going to tell you about what you should do every class. So I'm going to ask you to discuss on this example. The two questions are, first one, how to find theta 1 and theta 2. So theta 1 is the angle between W and V1, and theta 2 is the angle between W and V2. So the first question is how to find theta 1 and theta 2. And second question is how to find the vector W itself. So we are assuming that the length of vector is always 1. So work on these two questions, and when you're working on any questions like this, you have to write your idea or the thing that you discussed within the group in your own file. So this file, the content of the file is the evidence of your activities in the class. So for example, if I opened up this file, so don't work on other people's files or mess up with other people's content. So then I'm going to, let's say, probably start with questions. But it doesn't matter what the titles are. So find the angle theta 1. So by the way, the Markdown supports the LaTeX format of the formula. So I can use the formula here. So I'm going to erase. So I'm going to close out everything except for this. I'm not sure why always this new window pops up. So anyway, well, that's my question. And then, so my vector will be, let's say, V1 as left angle 1 over. I'm just showing you the example of how you write the write the formula. So I'm going to just write the simple example here. So here, and then you can preview your Markdown the Markdown file. So you have the title, the entire title for the file, and then there's a subtitle. You want to put whatever you want, and then you can put the formula like this, and then you want to write whatever you discussed, and you want to leave as your evidence of your discussions here. So once the classes are over, I'm going to close out the sessions. So you have to write your ideas on the file at the same time when you're talking to your friends or discussing. Because once you've done this, then we can always share what you guys are done here. So, yeah. So work on these two questions. How to find these two angles, theta 1 and theta 2. Although the values are here, try to think about how you obtain these values. And then second question is, think about how you actually obtain the component of the vector W using these two informations of inner product. So I'll give you about 2 or 3 minutes to think about on your own, and then you can talk about your ideas to your people next to you, and then bring up your ideas into groups. Okay. Start here.
This is not working. I can insert a.
So you have to go to the VS Code live share. So you have to click live share, not GitHub. Okay. Yes.
Not here where I have to go to how to find my.
You have to log in.
I have a PS Studio. And I have to go.
Did you click this link? Okay. Normally that asks you to log in. Here. No. Don't continue with anonymous because then you don't have permission. So, yeah, so it will ask you to log in. Yes.
And GitHub.
Yeah. GitHub. So the live share is a temporary tool. So I will figure out how to do it in a proper way. Yes.
Yeah, there is a angle between two vectors. Yeah. That what should I do with that if I find?
Yeah, have you talked to your friends
Yeah,
first?
sure.
Okay, how about you talk to your group member about this?
No, I mean that I should enter this information to him. So,
Oh, you want to put write something on here?
should I enter the information here?
If you want to, yeah, you can. Yeah, you have to log in. What is this? Is it Replit?
Yeah.
Don't go to Replit. Go to the live share. Replit doesn't work. So on the Notion site. Yeah. Oh, can you refresh? Refresh it. Yeah, open up again. Close and open. Okay, so talk to your friends next to you about the ideas that you thought about these two questions.
이거 누르는 게
Yeah. Okay.
잘 되는 것 같아서.
There's somewhere you're asking to log in, or just use web browser. Don't open the Visual Studio Code. Continue in web. Okay. Yeah, and then sign in here. You have to sign in. Okay. Click live share, and it pops up web browser. And they're asking whether you stay in anonymous or sign in. Don't press anonymous, okay? Sign in, press sign in. You have to sign in order to edit. Okay, so it's time to bring up your discussion into your group. So as I said, you're sitting front and back, so you have to turn your seat in order to talk to your group members. Okay. So talk to your group member. It's not about getting the answer. It's about sharing ideas. Okay. You don't have to. I'm not asking you to write the answer on your file. I'm not going to judge by the answer, correctness of the answer. You have to share your ideas on how you think about the questions.
왜냐하면 이게 보면 이게 코사인이라고 보이는데 앞에 코사인이라는 바로
What is it? Oh, 여기 sign in. You log in whatever you want. Log in here, or Microsoft or GitHub. Did you sign in? I don't think you signed in. I said you have to sign in. And you had probably ignored the message in here. Open again. Open again. Yes. Yeah. Yeah. Okay, so you guys should be talking to your group members instead of talking if you're doing on your own stuff. Don't be obsessed of writing. So okay, so you don't have to. I mean, it's not mandatory. It's you don't. I mean, there is of course some student not registered, so they cannot write anyway. But you don't have to obsessed about writing something on your file. It's just a record that you have done something. It's not a grade. Okay, you're supposed to discuss the questions that I laid here. All right, so that I can ask in group what you came up with. So turn yourself around to see who's your group members. Okay, start discussing. Who's your group in group 10? Who's your groups? Who's your group members? Okay, so turn yourself around. Which group are you in? Okay, so yeah, forget about this. So you guys talking about this, you guys should talking about these questions.
Preview.
Preview is what's it? Oh yeah, this one.
근데 그러면 이거 쓰는 방법 자체를 잘 모르는데 이런 거.
Yeah, just Google it.
아, 구글링.
So it's,
아까 그거 맞는데.
oh, okay, yes. What groups you guys are? 5? You guys are 5? All. So yeah, then it's hard to discuss if you're sitting right like this. But next time you probably have to sit front and back. Okay. Yes. So you are group 5. Okay. All right. You guys are all group 6. Okay. So how about those people? All of them? Okay, so yeah, how about start talking each other? The next time, try to sit front and back. Probably not in the same group anymore, but yeah. Are you guys group 6? Group 6?
Oh yeah.
Okay, so how about just pick. You three guys talk each other, and 3 of you guys talk each other.
오늘 날씨
Okay, so one more thing. Official language is English. So even you're in the group of Koreans, I expect you to speak in English. Okay, just practice. Consider this as a practice. So you should talk to your friends in the back. Okay. So you should turn around. They cannot, come here. So you have to turn yourself around. Are you guys all group 4? Have you talked to each other?
We're talking about
Talking about,
better, but don't know how exactly.
okay, did you talk to other members? Did you talk to her?
But
Okay, so talk in group. Okay, so are you group 4? Okay, so next time probably you have to sit front and back. Then if you sit like this, you guys can talk each other. You cannot hear what you're saying. What groups are you in? 8? Are you done talking?
not yet.
Not yet? You're not started talking? You start talking.
How can you describe the inverse function in
Okay, so we'll talk. How about asking other people here? Okay, so I'm going to ask a random group to share their ideas. So let's see. This one. Oh, yeah, I'll find another way of doing this. It's very hard to do this. Okay, so how about group 10? Where's group 10? Group 10, yes. Could you share how you thought about finding theta 1 and theta 2? Who's the leader here? Kim Dong-hyun? Yes. Could you tell us about your ideas? Have you discussed about the first topic? You're still discussing. Okay. So how about 9? Did I mention 9 before? So how about just 9? Jang Min-soo? Yeah. So could you tell us about the ideas, the first topics?
how to find theta 1?
Yes.
And we use the V1 and W is 3 over this 10, and V2 and W is 1 over 2.
Mm-hmm.
So cosine theta 1 equal 3 over 2 to 10. This is the first equation. The second equation is cosine theta 2 equal 1 over 2. Then we can solve the inverse, then we can get theta 1 and 2.
So did you get the theta 1? How did you get the theta 1? How did you get zeta 1? Anyone, any other group got zeta 1? Exact value of zeta 1 here? Did you get it? Group 8? How did you get zeta 1? Inverse cosine. How do you use the inverse cosine? So you don't have a inverse cosine function in your head, right? How did you compute the inverse cosine? Like if you're not a calculator, you cannot, do it on your head. I'm just asking what tool did you use to compute the inverse cosine? Did you get the value? Zeta 1 value? Did you actually compute the zeta 1? Huh? No? Okay, so any group got exact zeta 1? I mean, not exact, I mean, at least got similar number 18.45 degree as zeta 1. Is there any group got the number like that? No one? No one compute the zeta 1? Okay, so I think everyone agree that we need to know we need the inverse cosine, right? So what would you do if you need to compute the inverse cosine? What tool would you like to use? Huh? Anyone have any ideas? Because it seems like no one got it, but now let's just have a live discussion. What tool would you use if you need to compute inverse cosine? NumPy, that's a good option. So let's try to do that. So where is it? Oh, did I close it? Here. Okay, so NumPy. So I'm going to keep using the main.py because if I need to use this button in order to run the Python code, I need to use the main.py on the root folder. So just let's keep in mind, if you use the separate file and run it, then you need to use the shell command on the console menu here. But again, this is just temporary solution if you don't have any device that works for Python program. But eventually you need to bring your laptop every time, and your laptop must have your own Python environment. I'm pretty sure you guys taking a course on database AI. Not yet? It's not first year course? How about programming? This semester. So they're learning Python, right? No? What language are you learning in that course? What language are you learning? Python, right? So you're gonna learn Python, so you probably have to bring your laptop and Python ready. So anyway, so how do you use the cosine inverse? So there is a function called a cosine in the NumPy package. So I'm going to bring up the NumPy package. It's a name np here. So you can just delete everything we wrote here. So let me make it clean. Import NumPy as np, and I'm using a cosine. And what's the value? 3 over square root of 10. 3 over square root of 10. So square root is also a function that I need to compute, and it's also implemented in NumPy package. So I call this square root function from the NumPy package like this. And let's run this. So it's installing NumPy, so it takes a little bit of time. Yes, it's done here. So the answer is 0.32 something something. So it's a radian. It's not a degree. So if what if you want the degree instead of radian? What do you have to do? We just rescale, right? So 360 divided by 2 times pi. So pi is also a constant that defined in the NumPy package. So let's run this. You get 18.43. So here's our code, and try out yourself if it works in your computer or Python environment. So today is just a little bit of exercise, so it's a practicing session. So I will try out, I will look for other tools that you can work on or leave your works on the file. I think the VS Code is not working nicely as I expected. So don't be obsessed about not writing many things on your file today. So it's going to be changed probably next week. Again, it's a practice. What I'm expecting in every class is lots of discussions. So I'm not going to cover the lecture for the entire class. So I'm going to give a lecture for about at most 30 minutes in the class, and then the rest of the time I'm encouraging you to discuss. So what you have to do in the discussion is lots of talking, okay? So I'm also going to randomize the group every day, okay, every class, so that you can get to know as many people as much as possible. So, and again, the last thing that I want to request is prepare your laptop with your Python ready. And whenever you have a problem with a Python, I can help, but it's not impossible to help everyone because we have lots of people here, obviously. So you probably want to get used to how to program in Python. So probably you're learning Python this semester, but we are not doing any programming for a while. So if you keep following the code that I'm doing it here, then you'll be fine. So it's not hard. All right, so yeah, that's all of the things that I'm going to cover today. We'll see you on Friday. And if you're not registered and still wants to register this course, please leave after the course and talk to me. And other than that, see you on Friday.